Okay, welcome everyone. This video is just intended to be a quick GRE question review. I'm Juliet Anderson. I have recently taken the GRE and I'm in the process of applying to MBA programs. And I figured while it was still fresh on my mind, I would take a few of the GRE quant analytic questions and I would break them down for anyone else who's in the process of studying or about to take the test, or even if you're just thinking about taking the GRE and would like to know what to expect and what to prepare for. So, so for the goals and objectives, this is intended to be just a knowledge share, strategy explanation, how I got to my answer, what's the best way that I have figured out to get there. Quantitative reasoning review, right? So I've mentioned that we're going to go over 4 different quantitative reasoning questions, and just how to approach it, thinking about time and all of sort of the rules and regulations around the GRE. I would advise that if you have not yet taken a practice test, go ahead and pause this video. I did pull some of these from the ETS practice tests that I completed before taking the official GRE. And so you're more than welcome to take a look, but the best way to know how you're going to do and how you need to prepare is by taking them and then seeing where you need to focus. So I wouldn't want to taint anyone's experiences or create any biases, just so that you can get kind of a clean, fresh approach to how you're going to do on the GRE and then review later. I also wanted to supply some resources. So please keep in mind that I am, well, if you're preparing for the GRE, I am one of you. I'm not a professional, I'm not a tutor, I'm just somebody who's invested quite a lot of time into studying and wanted to share that with people. I didn't want it to just go into the test and then stop there. So I wanted to supply a couple of resources for anybody who is studying. Some of these may look familiar. Again, if you're starting out, these are really great places to start. ETS itself, that's where you'll schedule your test, that's where you'll take the test. They have a lot of great things. Again, that's where we pulled these questions from. The Khan Academy, they do a really great video walkthrough and tutorials on different types of questions and the strategy behind them. Kaplan and Princeton Review, also additional great resources for tutoring, studying, and getting explanations into questions. So with that, we're going to go ahead and jump into our first question. All right, so in this question, you can see that we are starting out with a triangle. We get a little bit of information here. We have PS equals SR. And then we have this angle right here, which is the X angle and the Y angle. So we're given a lot of information to work with. Sometimes it might be something to assume when you see something like this, that, oh, if PS equals SR, that must mean that this line right here is going straight down the middle, and that these two triangles are equal. It's a normal assumption. I can't say that I haven't made it myself, but this is where the application of critical thinking really comes in. So what we're trying to determine, let's make sure we know what they're asking. So we have quantity A, which is X degree, quantity Y, which is Y degree, or quantity B, which is Y degree, and quantity A, which is X degree. And then we're going to determine whether quantity A is greater, quantity B is greater, whether or not they're both equal, right? Like our sort of first assumption or first analysis, or maybe the relationship can't be determined at all given what we know. So let's think about this. Let's try and prove that in fact the two quantities are equal, since that's sort of where we're inclined to go. When we think about these two angles, we're not given any metrics. So we don't know what any of the measurements of the line segments are. We don't know what any of the degrees are, or whether they're equal or not. And so there's a couple of different ways in which this triangle could be drawn. So let's just sketch those out. We could do a really long triangle, and we'll draw that right down the center. Or it could be a really tall triangle, right? Very pointy top, very small up there, and again down the center. Great. And again, we have Y and X. I'm a little new with this pen. And X and Y. Now, the reason that I drew these triangles like this is because it's important to remember with the GRE that not all of the shapes are drawn to scale. So there's a chance that, without the metrics and without the measurements of this triangle, this could actually be skewed in any which way, as we've shown to the right. So in this scenario, if I were to draw these to scale versus just a sketch, but you can kind of see that the X degree is wider than the Y degree. And up here in the second one, the X degree is smaller than the Y degree. So because in this scenario, we've drawn out a couple of different solutions in which it could have, and the X is different in both and the Y is different in both, we have deduced that the relationship cannot be determined from the information given. We would need to know more about these degrees, more about the measurements of the triangles, and if we were able to do that, maybe we could deduce it. But for now, we have to understand that the relationship cannot be determined and move confidently and quickly on to the next question. All right, now the next question reads, a developer has land that has X feet of lake frontage. The land is to be subdivided into lots, each of which is to have either 80 feet or 100 feet of lake frontage. If 1/9 of the lots are to have 80 feet of frontage each, and the remaining 40 lots are to have 100 feet of frontage each, what is the value of X? So quickly, let's just kind of understand what we're trying to figure out here. We're looking for X, which is the feet of lake frontage total. It does give us that 1/9, we'll make a few notes over here, 1/9 of the lots are 80 feet each. Put an E for each. So we can deduce that if 9 is our total, then 8/9, right, the remaining lots are 100 feet each. Okay, so let's read this through again at the last sentence. If 1/9 of the lots are to have 80 feet of frontage each, and the remaining 40 lots are to have 100 feet of frontage each, what is the value? Okay, so we've got one more piece of information that we want to consider here, which will help us round out the question and to figure out our answer. So 8/9 of the lots are equal to 40 lots, which means that the 80-foot lots are 1/9 of the total. So if we put 8 over 9 equals 40, right? Because that's how much we'll find over X. X is the total amount of lots. So we'll do 40 times 9 divided by 8, solving for X. And X gives us 45 total. All right, now we're going to subtract 40 lots from that because right now we're looking for the 80 lots, which is 1/9, and that leaves us with 5 lots. All right, so this is a couple of steps, and what's really important is to just keep your stream of consciousness going so that you don't get lost. When it comes to questions like this, it may get a little confusing, but if you just work through the problem and make sure that you're paying attention to all of the clues or the information that they're giving you on the test, then you should have no problem finding your answer. So what we're going to do, because what we're answering for is what is the value of X, which is the total amount of lake frontage, I'm going to take 80 feet times 5 lots plus 100 feet times 40 lots, and then solve for that. So 80 times 5 is 400. 100 times 40 is 4,000, which leaves us with 4,400 feet of lake frontage. Going up to our questions and our answers, we're going to go ahead and mark 4,400 feet. Okay, we're on to our third question, which is a question about the tens digit and the units digit. And just remember that the tens digit is the second in from the right, and the units digit is the first digit or number on the right-hand side of the number. So looking quickly here, we're going to see that our tens digit is 7 and our units digit is 8. Our tens digit on the next number is 6 and our units digit is the next number, which is another 6. So the question's asking us if the x and y are the tens digit and the units digit respectively of the product 725,278 times 67,066, what is the value of x plus y? So we're just going to underline that because we want to make sure that we are answering the correct question. So as you're preparing for the GRE, I would recommend using the same type of calculator in which you'll have during the test. So some of you may have a scientific calculator that can do all different types of tricks and has tools on it, but it's a much simplified version for the GRE. And so being able to do everything yourself, right, relying very minimally on the calculator is going to serve you the best. So maybe with one of those big fancy calculators, you would be able to do this 725,278 times 67,066. But on the calculators given for the GRE, that is a much, much, much larger number than the screen will allow. And what it will do is it will eliminate those tens and units and other digits, kind of rounding it or showing you a different number in which you're looking for, because we're looking for those very finite numbers at the end. So what do? The best way to tackle this problem is to remember that in order to find the tens and units numbers of a product, all you need are the tens and units numbers from the numbers in which you're finding the product of. So that was a little bit of a tongue twister, but essentially all you need is what we've already underlined, the 7 and the 8 and the 6 and the 6. So if we were to pull that out and just say 78, we'll put parentheses, times 66, and I have a calculator off screen that I'm using, we are given 5,148. A little bit of a loopy 5,148, but we got there. And so that was a much faster version than maybe doing this with your calculator, doing it by hand, getting stumped. Pulling these out is very fast and strategically your best option. So we're left with 5,148. And just a reminder, we are trying to figure out what is the value of x plus y. X is our tens, y is our units. So we're going to do 4 plus 8. No calculator needed here to find 12. And we're going to go ahead and mark 12 in our answers. All right, we're on to our last question, and it reads, of the 750 participants attending a meeting of a certain association, 450 are members of the association, and the rest are guests. Of all the participants, half of the members and half of the guests are less than 30 years old. If one of the participants will be randomly selected to receive a prize, what is the probability that the person selected will be less than 30 years old? Okay, when you're in the throes of the GRE and you see questions like this, you may be inclined to rush. It seems like a lot of information. They're throwing a lot of numbers at you. But in fact, these can be your best friend on the GRE because they are giving you so much information. And all you need to do is to format it in the best way. So let me show you how. They tell us that we have 750 total guests. Right there, or participants. 450 are members. So that means that 300, or the rest, right? It says the rest right up here, are guests. I just took 450 from 750 and it left me with 300. Of all the participants, half of the members, so 450, we'll just put a 50% right here. And 1/4 of the guests, so for the 300 guests, we're just going to put a 25% right here, are less than 30 years old. So 30 years old. or less. If one of the participants will be randomly selected to receive a prize, what's the probability that the person selected will be less than 30 years old? So the first thing we want to know is how many people is this for 30 years old? So if we take 50% from 450, that will give us 225. And then if we take 25% from 300, that will give us 75. Sorry, it's getting a little crowded right there. So we'll move down here. So for 30, less than 30, we have 300 people, right? Because I took the 225 and I took the 75. So that means if we're looking at probability, the chances of us picking one of those 300 people is out of 750 people. Okay, so that's our answer, right? And if we were doing a fill in the blank, we could just throw that in there and that would be right. The tricky thing here is you might panic, right? You see this giant number and all of these very small fractions. So it's just a matter of deducing it from there. All right, so I'm going to take 10 from both of these, giving me 30 over 75. Then I'm going to take 5 from both of these, giving me 6 over, giving me 6 over 15. Then I'm going to take 3 from both of these, giving me 2 over 5. Now, you could probably figure without these in between that 300 over 75 reduces to 2 over 5. But just in case you're still in the beginning stages and working towards fractions and factoring them down, I went ahead and showed you everything in between. Looking at our options, I see that 2 over 5 is right here, and then I'm going to fill it in. All right, that was the end of our session. I am going to flip back to the original slide with the resources. I would strongly encourage you to check these out. If this video was helpful to you, please comment below with the schools that you're applying to. I'm really curious. You know, all of us are going through this all over the country and the world. And so I'd love to know if you have any other resources that you'd like to drop in the comments as well. But hopefully this video was helpful to you in figuring out some of these questions. It really is a grab bag. So the best you can do is just study as much as you can, prepare as much as you can. Again, I can't recommend those practice tests enough. And thank you all so much for joining. Good luck with your tests.